All right, we're doing slopes and equations of lines, and these are things that we have done before. You've done this in Algebra 1, so a lot of it should be a refresh, but you know, we're reaching back a little ways, so I understand if it's something that we haven't done in a while. Oh, we are mirroring over to my computer, so let's not do that while I'm also recording. All right, let's see here. I'm gonna go down here. Our goal is to classify lines as parallel, perpendicular, or neither by comparing the slopes of lines and by comparing the equations of lines. So we're going to take what we know about slopes and equations, and we're then going to apply it to this parallel and perpendicular information that we've been looking at in this unit. Okay? So slope is the ratio of the change in the y-coordinate, or the rise, to the corresponding change in the x-coordinate, or run, as you move from one point to another along a line. The slope criteria outlines a method for proving the relationship between lines, and you can use the slopes of two lines to determine whether the lines are parallel, perpendicular, or neither. So this is the important part that I really want you to hang on to. By looking at a slope, you can know if lines are parallel, perpendicular, or neither, just by looking at the numbers. And that'll come to you a little bit quicker as we go, okay? So in the box on your notes, you should be hopefully on page 14 there in your notes. I want you to make sure you have that slope equation down, that m equals that y2 minus y1 over x2 minus x1. And of course, we've also called slope the rise over the run in the past. But this is our professional equation there. M being slope. Yep. And then this being one of our points, the y2 and the x2, and this being one of our other points, the y1, x1 there. Okay. So let's look at some of these. I'm betting that we kind of know some of our slopes. In fact, if we were to go up here and look at some of these slopes, we could remember some of these. Let's look at this green line, okay? This line right here for those of us who are colorblind. If we remember how to do some slopes, if we pick out 2 points, this green line, as we follow it up, it crosses through 2 of those points. And rise and run, we go up 2 and then over 1, 2, 3, 4, 5. That means we went up 2 and over 5. Our slope is 2 over 5. Remember, we always go from left to right, okay? The reason being that if we were to go down and then over, it would be a negative slope, okay? So whenever a line goes down when we're going left to right, it's a negative slope, okay? So as we look at these lines, this green one, erasing that last one there, yep. This green one is a positive slope. This orange one is negative. This blue one is negative. And this red one is positive. Okay, just getting some of those pieces in place. Okay, so let's go back to where we were. Tricky slopes. These two are tricky. Vertical and horizontal slopes. I'm going to look at, rise over run. Which one is trickier? Horizontal or vertical? Let's do this one. Let's pick here and here for points. So here, with this one right here, for our horizontal, if we pick 2 points, -2 and -1, and 3 and -1, and do our equation. So we do our y's on top, -1 minus a -1, all over 3 minus a -2. We end up with, remember these become positive, 0 over 5. And remember, 0 divided by 5 is 0. Okay? So what you need to know is that horizontal lines equal a slope of 0. That's what you need to know there. Horizontal lines have a slope of 0. So keep track of that. Horizontal lines have a slope of 0. Now, let's look at vertical lines. What do they do? Let's pick 2 points for that. I'm going to pick right here and here. So that would be a point of, let's see, 3, 7, and 3, 4. So let's say 4 minus 7 over 3 minus 3. Well, that is -3 over 0. Uh-oh. Do you guys remember what happens when you divide by 0? Dividing by 0 is bad. That's the word. Do you guys remember it? It is undefined. If you do that in your calculator will yell at you, okay? You are not able to divide by 0. It's impossible. It's like saying putting 3 apples into 0 baskets. You can't do it, okay? It's impossible to divide -3 0 ways, okay? So a vertical slope is undefined. That's what it's going to be called. And in ALEKS, that is going to be the answer you have to give when they ask for the slope. Okay? Oh, wrong. That is here. That will be the ALEKS answer. Okay. A vertical slope is undefined. Look, I'm losing my voice now. That's great. All right, so keep that in mind. Tricky slopes. Horizontal slopes, 0. Vertical, undefined. Okay. And they are perpendicular to each other. All right, now let's look. Slopes of parallel lines. 2 distinct non-vertical lines. So we're not talking about these tricky ones, but as long as they aren't vertical lines, will have the same slope if and only if they're parallel. And all vertical lines are parallel. Okay, so any line that isn't vertical and has the same slope is parallel. And all vertical lines are parallel. So what they're saying is if you see a line that has a slope of 2/3 and another line, so slope of line 1 is 2/3 and slope of line 2 is 2/3, they're both parallel. Does that make sense? Okay. Okay, let's see here. Now, slopes of perpendicular lines. Now, speaking about non-vertical lines, because those are their own little things. Any other line, if you compare 2 lines, they will be perpendicular if and only if the product of their slopes is -1. Another way to compare them is if you look at a negative reciprocal relationship. So let me show you what this could look like. So 2 slopes that are perpendicular would look like this. slope 1 could be 2/3, and slope 2 could be -3/2. So if I multiply those, if I say 2/3 times -3/2, do you remember how to multiply fractions? We multiply across the top. 2 times -3 is -6. We multiply across the bottom, that's 6. And then we simplify, that's -1. And if we get -1, we know that they are perpendicular. So that means they're perpendicular. Oh, I'm going to run out of space. Perpendicular. Okay. Now, what do we notice about these two? We notice that one is positive. See this? One is positive, one is negative. And look at their numbers. The 2 is on the top, one's on the bottom, 3 on the top, 3 on the bottom. There we go. That's called a reciprocal relationship, where the numbers flip from top to bottom. Reciprocals. Okay? So negative reciprocal, that's what this is. Negative reciprocal. They change sign and they flip. Okay? So perpendicular slopes will change sign and flip. And then when you multiply them together, they will end up with a product of -1 when you simplify them. Okay? Then here's the big one. Vertical and horizontal lines are always perpendicular. Okay? Always perpendicular. So let's see this in being worked out. Determine whether A, B, and CD are parallel, perpendicular, or neither. And so they give us the lines. AB is 3, 6, and -9, 2. CD is 5, 4, and 2, 3. Graph each line to verify your answer. So you've been given graph paper and all the points there. I am not going to graph them in front of you right away. First, what I'm going to do is write out my slope, which is y2 minus y1 for x2 minus x1. I'm going to make each one of these one of my points, x and y1, x2 and y2, and I'm going to find my slope. AB's slope is going to be there. Let's see, wait a second. I'm going to write it this way. The slope of AB is 2 minus 6, because my y's go on top, -9 minus 3. 2 minus 6 is -4. That's -12. And then I simplify, becomes positive 1/3. Okay. Now I'm going to put my x1 and y1 over the top, x2, y2. It does not matter which point is 1 or 2. It does not. CD. Okay. 3 minus 4. 2 minus 5. 3 minus 4 is 1, negative. 2 minus 5 is -3. That is 1/3 because the negatives become positive. So positive 1/3. So if I've got a positive 1/3 here and a positive 1/3 here, they match. They are the same, which means they are parallel lines. And then we graph to verify. They have the same slope, so they are parallel. Okay. So if you need to write that down, go ahead. Pause me if you need to. All right. Now you're going to go ahead and try the same thing with these ones. Pause me and then come back and check your answer. Okay. Did you get that they were neither? I hope so. And you can see, looking at these, that these are not quite parallel. Parallel would have them more like that. There we go. Okay, determine whether each pair of lines is parallel, perpendicular, and either in these ones. So, RS and TU, they've got all the points down in here. Let's see, I'm looking down. So, RS and TU, there they've done the math. The slope of RS is 5/7 and TU is -3/2. And I can tell that they don't match. They're not the same. They don't look like they do that negative reciprocal thing. I'm going to double check with that product thing. So 5/7 times -3/2 equals -15/14. That is not equal to -1. So these are not parallel or perpendicular. There we go. Neither parallel nor perpendicular. Okay. So next one. They did the math on B and found that the slope was -7/3 and 3/7. And you can see that those have changed signs. They went, one's negative, one's positive, and they have flipped. You've got 7/3 and 3/7. And we could double check that. 7/3 times 3/7 is going to be -21/21, which is -1. So these are perpendicular. And you can tell by looking at it, it's not going to be parallel because we graphed it. Definitely not parallel. They are perpendicular. Okay. You go ahead and try this one. Determine if these are parallel, perpendicular, or neither. Pause me. Okay. Did you get that they were perpendicular? That all vertical and horizontal lines are always perpendicular?